So good afternoon to the session. So today's my topic is based on types of channel slope. So this topic is comes under the category of uniform flow. Uh, in uniform flow, the flow will classified into uniform flow, non-uniform flow as the two types. So these slopes in non-uniform flow, generally we classified into further two more types. That is, first one is rapidly varied flow, then second one is gradually varied flow. Rapidly varied flow, it means that the rapidly varied flow will occur in a short distance, while in a traveling of liquid, it will happen in a short distance. In gradually, second point, gradually varied flow will occur over a long distance, while a fluid is flowing in a long distance, this gradually varied flow will be occur. So based on this criteria, we have the different types of channel slopes. The first one is channel slope is mild slope, steep slope, critical slope. So these all the slopes are based on the uh, fruit numbers value, then ratios, then normal depth and critical depth. The comparison will show the name of mild slope, steep slope, critical slope. Mild slope is one which uniform flow is subcritical. So in mild slope, the flow is in a subcritical flow. So before the jump will occur, the mild slope will be created. So that is called subcritical. Steep slope is one which uniform flow is supercritical mode. So in the steep slope, the flow will be in a supercritical flow as well as in a critical flow. It is in a critical slope will occur in a critical flow. So this is the general thing in different types of channel slopes. Here, the mild slope, how we calculate the mild slope means normal depth which is greater than the critical depth. Okay. So generally, we have to find out this normal depth by and the critical depth. So there is some formula available in the problem. So while arriving all these values, we can make a comparison. So while comparison will goes that normal depth is greater than the critical depth, then we said that type of slope is called as mild slope. So likewise, the next we move into the second type, steep slope. When normal depth, here the y naught always indicates that normal depth, then yc will indicates that it's a critical depth. When y naught is less than the yc value, it is called steep slope. Then next thing is critical slope. Critical slope here, y naught which is equal to yc. So that is normal depth which is equal to yc, that is called critical depth, critical slope. So the classification of the slope will depend upon the roughness coefficient factor on this magnitude of the slope itself, and to lesser extent on the discharge same slope depending on the roughness of the bottom of the channel can be classified as the mild, critical, or a steep slope. So this is the different types of slopes will occur in a channel. So critical slope, here it is denoted as the symbol of SC. So it is arrived by it is defined by using the Manning's equation. So generally we have this Manning equation V equal to 1 divided by N R power 2 by 3 S power 1 by 2. So in Manning's N, by arriving this Manning's N, we have to find out the critical slope. Critical slope, the value will be, the formula will be Q into N divided by A C, that is critical area, then R is the critical mean depth. Okay. So this SC is nothing but critical slope. The general formula I already told you that Q equal to A into V. Here the velocity for the Manning's coefficient will be, the Manning's formula will be V equal to 1 divided by N R power 2 by 3 S power 1 by 2. So that S power 1 by 2, here we take it as a SC. Then RC is nothing but, that is the area of the wetted area divided by the wetted perimeter. So that's the definition will be given here, where AC, PC, RC are the area, wetted perimeter, hydraulic radius. Hydraulic radius is nothing but R. Wetted perimeter is capital PC, then wetted area is capital AC. Okay. Of the flow computed by using the critical depth YC for the discharge capital Q respectively. Then the classification of slope becomes mild slope. So when it comes as a mild slope, when S naught is less than the value of SC, that is, here the S indicates that the slope is the naught, it means that in suffix naught, which says that the normal slope, critical slope. Okay. So those do comparison will says that which one is higher and which one is lower. So based on this criteria, we says the slope is mild, steep, critical, horizontal slope, adverse slope. So generally the slope can be classified into these 5 types. So mild slope S naught value is less than SC value. Then steep slope S naught is greater than SC value. Then critical slope S naught which is equal to SC value. Then horizontal slope S naught which is equal to 0. Then adverse slope S naught will less than the 0. So these 5 factors will indicate the slope classifications. So slope classifications are based on this criteria. Okay. Then a basic assumption. Next topic is basic assumption and equation for the gradually varied flow. So this is the gradually varied flow. The gradually varied flow will arrive from the formula of the Manning's formula. Okay. So velocity Vn into R power 1 by 2 S R power 2 by 3 S power 1 by 2. So this is the common formula for Manning's formula. So from that Manning formula, we've arrived the SF value. Okay. So we made the few assumptions on the applications of gradually varied flow and have some assumptions, basic assumptions for the gradually varied flow. For that gradually varied flow, the first assumption, the channel is a prismatic one. The channel, in previous lecturing, I have delivered that what is prismatic and what is non-prismatic. Okay. So once again, we recall into the same topic, the prismatic, which means that the channel have the proper cross-section, area, shape, size, etc. When it comes to the non-prismatic channel, non-prismatic, we can does not consider the cross section. It may be an any irregular in the form of shape, size, and etc. Okay. So then bed slope of the channel is very small. Then flow is steady, and hence the discharge Q is constant. The pressure distribution in a ballast vertical direction at any cross section is hydrostatic. The roughness coefficient is constant for the length of the channel and does not depend upon the depth of the flow. The uniform flow formula like Checkis and Manning's formula are also applicable to gradually for determining the slope of energy line. Then next point is the channel is prismatic. There is no lateral inflow and outflow. So here we have to first take the equation, that is total head equal to datum head, velocity head, the velocity head or potential head or pressure head. So this is the general thing. So from this formula, we are going to arrive at derivation. So solving the derivation. So from this derivation, now let us examine the flow in weather to obtain a complete description of the longitudinal flow variation within a uniform transition region. The energy equation at any cross section will be taken as H equal to Z plus Y plus V square divided by 2G. So this is the first equation. From that equation, we are going to derive the equation with respect to the X. When we are going to derive the H, it means that dH by dx, which is equal to d by dx into Z plus y plus v square divided by 2g. By arriving this formula, we can get the equation in the form of dy, that is here that dy by dx. So this is the equation of the dynamic equation of gradually flow. So this equation can be written as dy by dx equal to s naught minus sf divided by 1 minus Froude number, that is fr square. Okay, so what is the dy by dx? It represents the dy by dx, which is represent the variation of the water depth along the bottom of the channel. So in bottom of the channel, the depth will be differ from one place to another place. So those difference can find out by using the formula of dy by dx equal to s naught minus sf divided by 1 minus f r square. So these formula will says that how the difference will get between these points. Okay, so mainly it will be used to calculate the depth, what the depth will occur in the fluid flow. Okay, so this is the uh, thing behind in the uh, gradually varied flow equations. Okay, so already we know this equation, then mild flow, then everything. Okay. So in briefly, we seen about all this type of flows. So first one is mild slope. Mild slope, the possible water surface profile or the mild slope profile. So already says that how we differentiate this mild flow by comparing this equation. Y naught is less than the YC value. Okay. If it is being like this, we say it as a mild slope. So this is the drawing representing the mild slope water surface profile. Then steep slope. When water will goes into the horizontal asymptote, when it will reflect to the down. So this type of slope is called as steep slope. So this is the drawing shows that steep slope. So water surface profile along the steep slope. Then this one is the critical slope, that is y naught, which is equal to yc. So this is called critical slope. So this one is the horizontal slope. So horizontal slope will be always possible in a fluid flow. So this one is the horizontal slope. Then adverse slope. Okay. So these are all the different types of flow available in a flowing of fluid in a channel. Okay. So next, the computation will follow in a gradually varied flow by using all these three methods. So the computation of the gradually varied flow involves basically the solution of dynamic equation of gradually varied flow. So where can we can get this equation, and how it can be solved in a different ways. The main objective of computation is to determine the shape of the flow. So it means the shape of the flow means what kind of the cross section the water will get into the flow. So that is called as the cross section of the flow. Here we can compute it by using the three methods has been used to computing the graphical representation. So generally there are graphical interpretation integration method, direct integration method, then step method. So these all has been used to find out this gradually varied flow from the dynamics equation. Okay. So direct integration method differentiate the equation of gradual flow can be expressed implicitly in the term of y for all the types of flow cross section. Hence, a direct and exact integration of the equation is practically impossible. When it is impossible, in this method, the channel length under the consideration is divided into short reaches and integration is carried out by the long range steps. So in the step method, in the generally the step method, the channel is divided into short reaches. The computation is carried out step by step method from one end of the ridge to another end of the ridge. So there is a great variety of the step methods. So some method appear superior to other in a certain respect, but no one method has been found to be best in all application. So standard step method will be the best application for the solution for the all type of applications. The most used commonly step method are direct step method, then standard step method. So direct step method, how we equating? So this is the form of equating this direct step method. Directly we can include, it is possible applicable to the prismatic channel. Okay, and the energy equation between the two section will be the considerable one. Okay, so that's all about this topic, and thank you.